Hi, welcome to the third video for section 5.1. This video is going to focus on finding distributions when we're looking at 2-to-1 functions of a continuous random variable. So far we've considered only 1-to-1 functions that are monotone increasing or monotone decreasing on the support of x. And in this video we're going to look at sort of how we would start to try to consider finding the function, the distribution function for a situation where our transformation is not monotone and is not 1-to-1. So for example, if we let the probability density function f of x equal x squared over 3 on the support from -1 to 2, and we take the function y of x equals x squared. I'm going to start off by thinking about what the support of y would be. So the easiest way to do this is to graph y as a function of x over the support. So I've done that here. I've got x going from -1 up to 2. I've got x squared, which is my y. And I can see that the values that y take on range from 0 up to 4. So that's going to be my support for y. So 0 is less than y is less than 4. Okay. So there's my support. Now if I want to start finding the distribution function, I'm going to be thinking about f of y, which is the probability that y takes on a value less than or equal to little y. And I'm going to kind of just look at my graph and say, okay, well here I can see that when x is between -1 and 1, and when y is between 0 and 1, I've got the situation where I'm not 1-to-1 in that range. Right? I've got two different values of x that have the same value of y. So I'm going to start by looking just in this range and say, okay, let's look. So for values of y that are between 0 and 1, if I want to find the probability that y takes on a value less than or equal to little y, I can rewrite this as the probability that x squared, because y equals x squared, is less than or equal to little y. And in this range, this would mean that x would have to be between the square root of y and negative square root of y. So I'm using my distribution function technique. I'm isolating x, but because it's 1-to-1, if my value is less than y, it means the square root has to be less than in this range here, right? But not both positive and negative. Now I can find this using the cumulative distribution function of x, because I'm looking here. Probably that x is between these two values is going to be the integral from the lower limit to the upper limit of my probability density function, x squared over 3 dx, which if I do my integration gives me x cubed over 9 . And once simplified, it's going to give me 2/9 y to the 3/2. So this is my cumulative distribution function for y, if y is between 0 and 1. If I want to find my probability density function, I'm going to take the first derivative of that cumulative distribution function. So this is going to give me 3/2 times 2 to the 9th times y to the 1/2, which gives me 1/3 y to the 1/2 power. I'm sliding off the screen. There we go. Okay, so this is for y between 0 and 1. Now, if I want to, I need to also find the probability density function for values of y. So I've done 0 to 1. Now I need to go from 1 to 4. And here it's a monotone increasing function. So for y between 1 and 4, the probability that y is less than or equal to little y, which is my fy of y, is equal to the probability that y is less than 1 plus the probability that 1 is less than or equal to y is less than or equal to y. So it's the probability that y is less than 1 plus the probability that y is between 1 and my value y. I can use my cumulative distribution function that I found earlier for this range from 0 to 1 to find the probability that y is less than 1 is 2/9. Plus, now I'm going to substitute in my function x squared of y. Find this by integrate. Oh, sorry. Should do one more step here first. I want to isolate my x. So this is 2/9 plus the probability that 1 is less than or equal to x is less than or equal to square root of y. Right? Isolating x by its own center. So now I've got my 2/9 plus, I can find this probability by integrating from 1 to the square root of y. My probability density function, x squared over 3 dx. This is ultimately going to give me 2/9 plus x cubed over 9. And evaluate that 1 and the square root of y. This will give me 1/9 plus y to the 3/2 times 1/9. And now if I want to find my probability density function, f of y, I'm going to take the first derivative of the cumulative distribution function, which is going to give me 3/2 times 1/9 times y to the 1/2, or y to the 1/2 over 6. So now to find my probability density function, I'm going to put these two pieces together. Remember that if y is between 0 and 1, my probability density function is 1/3 y to the 1/2. And we just found up above that for y between 1 and 4, the probability density function is 1/6 y to the 1/2, and would be 0 otherwise. So mostly when we're working with functions that are not monotone and are 2-to-1 functions, we need to graph the function to start with and just really think about what it would mean for y to take on a value less than a particular value of little y. Okay? It's not really super complicated, but it just requires graphing the function and really thinking things through. Hopefully this gives you a good start working with finding distributions of 2-to-1 functions. Let me know if you have any questions. Thanks.